Okay, welcome everyone. Today I'm going to be discussing the problems and solutions for the AMC 8 from 2014. I'm just going to go through the questions in order and explain the solutions. If anyone has any questions, feel free to ask. But yeah, I'll just get started now. Okay, let's start with problem 1. So Harry and Terry are each told to calculate 8 minus the quantity 2 plus 5. Harry gets the correct answer, and Terry ignores the parentheses and calculates 8 minus 2 plus 5. And we're told that Harry's answer is h and Terry's answer is t. We want to find h minus t. So if we evaluate it with the parentheses, 2 plus 5, that's 7. And then 8 minus 7 is 1. If we ignore the parentheses, we'll start with 8 minus 2 to get 6. And then add 5, that's 11. So for h minus t, that would be 1 minus 11, which would be negative 10. There's our first answer. Okay, on to question 2. Paul owes Paula 35 cents and has a pocket full of 5-cent, 10-cent, and 25-cent coins. And we want to know the difference between the largest and smallest number of coins that can be used. So for the largest number of coins, we obviously want to use the least valuable coins. So using only 5-cent coins. So since she owes, or there's 35 cents owed, and the coins are 5 cents, that's going to be 35 divided by 5. It's going to be 7 coins, right? And if we want to minimize the number of coins, we'll start with a 25-cent coin. And then because we can't have any more 25-cent coins, we're going to go to a 10-cent coin next. And that would be 2 coins. So that would be 2 coins, right? And then 7 coins minus 2 coins is going to be 5 coins, yes. So the difference is 5. And, oh, there's my challenge. Okay. Just a heads up, I am recording, so if you want to turn off your video just for privacy reasons, it's up to you. Okay. So on to the third question. Isabella had a week to read a book for a school assignment, and she averages 36 pages per day for the first 3, and then 44 pages a day for the next 3. And then she reads 10 pages on the last day to finish the book. And we want to know how many pages there are total. So on the first 3 days, if she averages 36 pages a day, that means she's going to read 3 times 36 pages. 3 times 36. That's how many pages she's going to read in the first 3 days. That's 108. The second chunk of days, the 4th, 5th, and 6th day, she reads 44 pages on average. So we're going to have 3 times 44. And that's going to be 132 more pages. And then on the last day, it's just 10 pages. So if we add all of these up, 108 plus 132 plus 10, we get our answer of 250. So those are the answers for the first 3 questions. Okay, let's move on. Alright, we have the sum of 2 prime numbers is 85, and we want to find the product of these two prime numbers. So if we think about the prime numbers, we know that every prime number other than 2 is odd. So if our two prime numbers are both odd, they're going to add up to an even number. But since the sum of the two numbers is odd, we know that one of the primes must be 2. And that tells us that the other prime would be 83, since they must add up to 85. And if we take the product of these two, we'll get 166. Okay, next question. Margie's car can go 32 miles per gallon, and each gallon costs her $4. So we want to know how many miles she can go off of $20. So first we can see that with $20 she can buy 5 gallons of gas, since 20 divided by 4 is 5. And then with each gallon she can go 32 miles. So then we'll do 5 gallons times 32 miles per gallon to get our answer of 160. Okay, on to question 6. We have 6 rectangles with a common base, a base width of 2, and then the lengths are 1, 4, 9, 16, 25, and 36. And we want to find the sum of the areas. So like a diagram probably looks something like this. Right, you have a bunch of rectangles, base width is 2, and then they go up really quickly because 1, 4, 9, they grow pretty quickly. But since each rectangle has a base of 2, to find the total of their areas, we can just, well, we know it would be 2 times 1 plus 2 times 4, and so on, right? Since we would take 2 and multiply by each of these heights. So a faster way would be, therefore, to add up all of our heights beforehand and then multiply by 2. So if we add up our heights, we get 91. 36 plus 25 plus 16 plus 9 plus 4 plus 1, that's 91. And then if we multiply by our base width of 2, we'll get 182. And notice they put 91 here to trick you if you forget about the common base. Okay, on to question 7. There are 4 more girls than boys in Miss Rob's class of 28 students. We want to know the ratio of girls to boys. So the way we could first think about this is if there were exactly 14 boys and 14 girls, right? That would be 0 more girls. And then for every girl we add, we also have to subtract 1 boy. So that means that if we go to 15 girls, that'd be 13 boys, and a difference of 2. So if we do that one more time, we will get 16 and 12. And that's the difference of 4 that we want. So now to find the ratio, it's just 16 divided by 12. And if you take out a common factor of 4, we get 4 to 3, right? This is 4 times 4. This is 4 times 3. So our answer is 4 to 3. Okay. 11 members of the middle school math club each paid the same amount for a guest speaker. And they pay their guest speaker 100 and A times 10 and $2. And we want to know what the missing digit is. So I'll scroll down now for the answers. Okay, so we need this number to be a multiple of 11, since the 11 people all paid the same amount. So what we just have to do is plug in each of these as the tens digit, and we would find that 3 would give us 132, which is 12 times 11. So each person pays $12. And so our answer is 3. So that's how you'd solve problem 8. Okay. Problem 9. We have a geometry problem. So we have a triangle ABC, and we have a point D such that BD equals DC. So I'll draw hash marks here to indicate that. And we also know that BCD is 70 degrees. They've drawn that here. And we need to find ADB. So the first thing we see is that BDC is an isosceles triangle since two of the sides are equal. And whenever we have an isosceles triangle, we know that the two base angles are the same. So this will also be 70 degrees since we also had 70 degrees over here in the corner. And then looking at this same triangle, BDC, we know that the sum of the angles in a triangle has to be 180 degrees. So since these two add up to 140, the last one here must be 40 degrees. 140 plus 40 is 180. So we have 70, 70, and 40. Now finally, to find ADB, we know that ADC forms a straight line. So this angle in total must be 180. So since this part is 40, the remainder would be 140. Yeah, 140 degrees. And so our answer is D. Okay. Now another way we could have solved this is to notice that these two angles, the 140 and the 40, would have to add up to 180. And we also know that the 40 added with these other two angles also add up to 180. So we could actually show that whatever this angle is and this angle is, we can add those two up and it would be the same as this angle. So these two angles over here add up to the third angle. Okay, on to problem 10. The first AMC 8 was given in 1985 and has been given annually since then. Samantha turned 12 the year she took the 7th AMC 8. And we want to know what year she was born in. So if the first AMC 8 was given in 1985, then the 7th one would have been given 6 years later. So 1985 plus 6 is 1991. That's when the 7th AMC 8 would have been. Now she turned 12 in 1991. 12 in 1991. Then she would have been born 12 years before that. So we would do 1991 minus 12. And we would get 1979. That's our answer. Okay, on to problem 11. So Jack wants to bike from his house to Jill's house, which is located 3 blocks east and 2 blocks north. So if we start with his house, then we know we have to go 3 blocks east and 2 blocks north. So we'll fill in this. And after biking each block, he can continue east or north, but he needs to avoid a dangerous intersection 1 block east and 1 block north of his house. And we want to know how many ways he can reach Jill's house by biking 5 blocks. So we're told that the one place we cannot go is right here. So pretty much the remainder of our paths looks something like this. that's all the paths we can take. So the first option would be to start by going upwards, and then we would have to go east for the rest. So 2 north and then 3 east. That's one option. And we could also start by going 2 blocks east. Then there are a few more options. We could go 1 more east and then 2 north. We could do this sort of zigzag here, going 1 north, 1 east, and then 1 more north. Or we could go 2 north and then 1 east. So that's 3 more options. And so our total, we have 4 choices for how to get there. So you can see this intersection takes out quite a few possibilities, actually. All right, let's keep going. Does anyone have any questions so far? No? Okay. So we have a magazine with 3 celebrities as well as their baby pictures, and we do not know how they match up. But then the readers are asked to match them correctly. And we want the probability that a reader who guesses randomly will guess all of them correctly. So I'll say the celebrities can be A, B, and C. And then their baby pictures can be A, B, and C, but lowercase, let's say. So we want first the probability that they match A to A. Well, the probability that they do that is 1/3, because there are 3 choices for what they could have connected the uppercase A to. And so there's only one possibility that works. So 1/3 chance. Now for the second picture, assuming that they got the first one correct, we would only have, we will now have a 1/2 chance, because the B can be connected to only B or C. A has already been done. Now we have a 1/2 chance. And then finally, we want to connect C. There's only one option left, but it's definitely correct. So we can write times 1, doesn't really matter. It's not going to affect our answer. Either way, we'll get 1/6. Multiply the numerators, multiply the denominators. Bottom is 6, top is 1. So we get 1/6 as our final answer. Okay. I'll keep that there. On to question 13. So we have n and m, which are integers, and we know that the sum of their squares is even. And we want to know which of the following is impossible. Well, the only way for n squared plus m squared to be even is if n squared and m squared are both even or both odd. And the square of an even number is even, while the square of an odd number is odd. So that pretty much means that n and m have to both be even or both be odd. But both of those are possible, so it's not A and it's not B, since those are saying they are both even or both odd. For n plus m to be even, well, if n and m are both even or both odd, this will be true. So this is actually always true for if this is true. So this is definitely not correct. Now for n plus m to be odd, the sum of these two numbers can only be the same if one of them is even and one of them is odd. But we've already said that they both have to be even or both of them have to be odd. So D is our answer, right? The sum of 2 evens or 2 odds cannot be odd. Obviously, it's not even, right? Just showed that one of them worked. Okay. So we have a rectangle and a triangle with the same area. And then we put them together to make a trapezoid. And we want to find DE. So first we can find the area of this rectangle pretty easily. It's 5 times 6, length times width. So that's 30. And since it's a rectangle, the opposite sides must be equal. And we also know that the triangle has the same area as the rectangle, also 30. So now we can say for this triangle, 5 times the base, if you see 5 as the height and CE as the base, 5 times the base divided by 2 equals 30. That's their area formula for the triangle, and we already know the area is 30. So if we solve, we'll get that the base is 12. 5 times 12 is 60. 60 divided by 2 is 30. So CE is 12. Now to find DE, we'll use the Pythagorean theorem. So we know that DE squared equals 5 squared plus 12 squared. This in total is 169, so DE would be 13. 13 squared is 169. And I'll let you confirm that yourself. Oh yeah, so our answer is 13. Okay, any questions? Okay, sounds good. So we're given a circle, and we're told that the circumference is split into 12 equal arcs, marked by the letters A through L. And we want to find the number of degrees in x plus y. So we'll want to know these angles since we're in the same triangle. So first we can notice that because it's a circle, OA and OE are going to be the same. They're both radii of this circle, right? OA is a radius, OE is a radius. So that means that, we already talked about this, but in an isosceles triangle, the base angles are equal, so we've also got x over here. And similarly, we've got more radii, OG and OI. So this is also y. Now, to find these central angles, we need to look at how many arcs they cut off, basically. So we know that 12 arcs in total are equivalent to 360 degrees. So this arc over here has 4 segments, 4 arcs. So that's going to be 120 degrees, 1/3 of the total. So we know that this angle right here is 120 degrees. And over here, since IG cuts off 2 of these arcs, we know it's going to be 60 degrees, half of this 4 arc over here. Or alternatively, we could come back over here and say 2 arcs is 1/6 of the total. So that'd be 60 is 1/6 of 360. And then using the fact that the angles in a triangle add up to 180, and the fact that the base angles are equal, we can find what our missing angles are. So we know all the angles over here are 60, and the 2 angles over here are 30. So every triangle has angles adding up to 180, and our 2 base angles are equal. So x and y, they add up to 90. So 30 plus 60, that's 90. Okay. This one might be tricky. Any questions? No? Okay. So the middle school basketball conference has 8 teams, and every season each team plays each other conference team twice, and also plays 4 games against non-conference opponents. And we want to know the total number of games involving these teams. So we'll start by considering all the games within the conference. So we need 2 teams from within these 8. Now we have 8 choices for the first team participating, and we have 7 choices for the second team, because we obviously cannot have the same team facing itself. That would not make any sense. So this would seem like 56. But if we first, let's say we first pick team A and then pick team B. Well, that's the same matchup as if we picked team B and then team A. Right? Okay. Sorry. Okay. So since picking A and then B is the same as picking B then A, we've basically counted every matchup twice. Once with A first and once with A second, so to speak. So we actually have to divide this by 2. Instead of 56, we get 28. But then since each of these teams plays every other conference team twice, we actually have to multiply by 2 again. So this is sort of undoing that. And we'll get 56 again. Now each of these 8 teams also plays 4 games against non-conference teams. So each of these 8 teams, 4 games, is 32. So we'll add up the conference games and the non-conference games to get a total of 88. Okay. Let's do problem 17. So George walks 1 mile to school, and usually he goes 3 miles per hour. But today he walks the first half mile at only 2 miles per hour. So we want to know how many miles per hour he has to go the last mile or the last half mile in order to arrive just on time. So if he usually goes 3 miles per hour for 1 mile, that would usually take him 20 minutes. That's 1/3 of an hour. And today, going 2 miles per hour for a half a mile. Well, going 2 miles an hour would usually take 30 minutes for 1 mile. So for a half mile, that would take 15 minutes. So that leaves us with only 5 minutes to run the last half mile. So if he goes a half mile in 5 minutes, that's the same as going 1 mile in 10 minutes. Now, if he runs 1 mile in 10 minutes, that's going 6 miles an hour. Because in 6 times 10 minutes, 1 hour, he would go 6 times 1 mile, 6 miles. Okay. So, question 18. 4 children were born at the city hospital yesterday. And if we assume each child is equally likely to be a boy or a girl, we want to know which outcome is most likely. And we're given all 4 boys, all 4 girls, 2 of each, or 3 and 1. So how many ways are there for all of them to be boys, right? We want to count the number of ways for each possibility and then basically just say which one has the most possibilities. So we can, I guess, call the people A, B, C, and D. Now, if all 4 of them are boys, there's obviously only one possibility. And same for all 4 being girls. Now, if 2 of them are girls and 2 of them are boys, we have a few more possibilities, which we can count pretty easily. So I'll just mark off which one of the 4 people are girls. So we could have A and B, A and C, A and D, B and C, B and D, or C and D. So we have 6 possibilities. And notice that I'm keeping this organized by starting with all the possibilities that have A, and then all the ones that have B but not A, and then all the ones that have C but not B or A. So we have 6 possibilities here. Okay, so now we need to find the ones where 3 of them are of one gender and the last one is the other. This is actually a little bit easier to consider. If we have just one boy, then there are 4 possibilities. Any of the 4 could be a boy. And if one of them is a girl, then it's the same. There are 4 possibilities, right? Any of the 4 children could have been. So we actually have 4 plus 4, which is 8 possibilities. So clearly, the outcomes are not equally likely, and our answer is D, since we have the most possibilities. Okay, any questions about that problem? Okay, on to the next question. We have a cube with 3-inch edges to be constructed from 27 smaller cubes with 1-inch edges. We were told that 21 of them have been colored red and 6 of them are colored white. And we want to construct the cube so that the smallest possible surface area is white. And we want the fraction of the surface area that's white, assuming that we have the smallest possible here. So the first thing we need to do is find the surface area of this cube. Each side of this cube is 3 by 3, so that's going to be 9 on each side. And then since there are 6 sides, that would be 54. 6 times 9, 54. And so all we have to do now is figure out what's the smallest amount of white that can be showing. Well, if the cube in the very center is white, it won't show at all. That's pretty good. So we can have the first white cube be in the center. For the other 5, the second best place to put it would be in the very center of a face. So one face of that white cube would be showing, but the other 5 would be hidden. So basically we have 5 faces with a white cube in the center, and that's going to be 5 square inches of white. So that's going to be 5 over 54. Our answer is A. And this 2/9 answer is what we would have gotten if we had put in a white cube in the center of every face. But obviously putting a white cube in the center where it's hidden by all the faces is going to be better. Any questions so far? Okay, let's go on to question 20. So we have 3 circles with radius 3, 2, and 1, and we want to find the area of the rectangle that is within this rectangle, but outside the circles. So we're basically looking for this area here, right? So first we can calculate the area of the rectangle. The area of the rectangle, well, this length is going to be the sum of the radii of circle B and circle C. It's going to be 3 and 2 for a total of 5. So we know that we have a length of 5. And we're actually given the width right here, C to D. So we have a width of 3. So length times width, our area for the rectangle is 15. Now we have to find the area of these quarter circles so that we can subtract them. So first we'll need to know that the area of the circle, of any circle, is pi times the radius squared. So for this first quarter circle, the area of the entire circle would have been pi times 1 squared, which is obviously just 1. So pi times 1 is pi. Now since it's a quarter circle, we want to divide by 4. So we have pi over 4. That's our area for the A quarter circle. And for the B quarter circle, we'll basically do the same thing. Pi times 2 squared is 4 times pi. Now, since it's a quarter circle, we divide by 4. 4 pi divided by 4, that's pi. And for the final quarter circle, we have pi times 3 squared. That's 9 pi. And then we have to divide by 4. So if we add up all of this, we'll get 3.5, I won't use 3.5, I'll use 7 halves times pi. So we have to subtract that from 15. And if you use pi equals 3.1, you could also use 3.14. You can just approximate for this question because it's asking you to find the closest answer. But you'll get 4.0 as the closest. Okay, any questions for that problem? No? Okay. Alright, let's go on to question 21. So we have 7-digit numbers that are each multiples of 3. Now we want to know a possible value of C. So the divisibility rule for 3 tells us that the sum of the digits has to be divisible by 3. So we'll look at the sum of the digits in the first number. So adding up the digits that we already know, 7 plus 4 is 11, plus 5 is 16, plus 2 is 18, plus 1 is 19. So we have 19 and A and B. And we know that 3 has to be a factor of this. Now looking at the second number, we have 3 plus 2 is 5, plus 6 is 11, plus 4 is 15. So we have 15, and then our 3 variables. So we need to find C. In order to do that, we need to know A plus B first. So if we treat A plus B as one number, we'll see that A plus B has to have a remainder of 2 when divided by 3, because 19 has a remainder of 1, because 18 is a multiple of 3. So that means a plus b must be remainder 2, so that they can add up to remainder 3, which is the same as remainder 0. So we can basically just say that a plus b right here, remainder 2. 15 is already a multiple, so we basically can just ignore it. And then for c, well, this has to have remainder 1, because 2 plus 1, we already know. That's how we're going to get to remainder 3, which is the same as remainder 0. So we want to find the number that has a remainder of 1 when divided by 3. And 1 is the only number that works. So our answer is A. Okay. Does anyone have any questions about that question? Okay. On to the next one. Alright, we have a 2-digit number such that the product of the digits plus the sum of the digits is equal to the number. We want to find the units digit. So let's write the number as 10a plus b. And that's going to be the 2-digit number AB, right? And we're told that the product of the digits, so A times B, plus the sum of the digits, A plus B, is equal to the number, which we said was 10A plus B. So we see that we have B on both sides, so we can cancel these out. And then we have A times B plus A equals 10A. So if we subtract A from both sides, this 10A would become 9A. So we have A times B equals 9 times A. So obviously B has to be 9. So we want the units digit, which is actually B. So 9 is our answer. And notice that we didn't actually find A, but they weren't asking for it. So A actually can be pretty much any number. So that's why they didn't ask for it. Okay. Any questions about that? All right. So we have 3 members of a softball team who have the following conversation. Ashley says that all of their uniform numbers are 2-digit primes, and then each of them says that the sum of the 2 uniform numbers of the other 2 people is the date of their birthday sometime in that month. So for example, Bethany says that it was, or the sum of Caitlin and Ashley's numbers is the date of her birthday earlier that month. When Caitlin says the sum is later this month, and Ashley says it's today. So we want to know the number that Caitlin has. Well, the key to this problem is that there are only at most 31 days in a month. So taking just the smallest 2-digit primes, we have 11, 13, 17. And we see that 13 plus 17 is already 30. So if we go any higher, we're going to have problems because adding 2 numbers could go over 31. So these are definitely the only possibilities, 11, 13, and 17. Now we can see that the person wearing 11 would see a sum of 30. person wearing 13 would see a sum of 28, and the person wearing 17 would see a sum of 24. And Caitlin, we want to know what her number is. Well, she says that the sum of the other two people's uniform numbers is the date of her birthday later this month. And because one of the people has today's date, one of the people has an earlier date, Caitlin must have seen two numbers that add up to 30. That's the only one that could be later. 28 has to be today, and 24 has to be earlier. So if Caitlin sees 30, which was the 13 and the 17, she must be wearing the 11. So does that make sense to everyone? Okay, assume it does. So problem 24. One day, the beverage barn sold 252 cans of soda to 100 customers, and every customer bought at least one can. We want to know the maximum possible median for the number of cans bought. So, since we have 100 customers, the median is going to be the average of the middle two people, since we have an even number of people. And that's going to be the 50th and the 51st person that we're going to be averaging. So we know that every number after the 51st has to be at least as big as the 51st. But every number before the 50th can be as small as we want. So in order to maximize the 50th and 51st numbers, let's make the first 49 all ones. And obviously this will continue. So 49 people each having one can would leave us with 203 cans. 252 minus 49. And these 203 cans, we need to split these as evenly as possible among the remaining 51 people. Now, unfortunately, 203 is one less than 51 times 4. So that means that the 50th person would only get 3 cans, but everyone else would get 4. Because that would be 4 times 51 minus 1. And that would add up to 203. So the median is the average of these two people in the middle. So it's 3.5. So you can see with just one more can, the answer would have been 4. That's the answer to number 24. Okay, on to the last question. So we have a straight 1 mile stretch of highway, 40 feet wide, which is closed. Now Robert rides his bike on a path composed of semicircles, and he rides at 5 miles per hour. So we want to know how many hours it'll take him to cover the entire stretch. So one thing that we realize is that the fact that it's 40 feet wide doesn't really matter, because basically what the problem is saying is that instead of traveling on a straight line, he's taking the semicircular path. So we can just calculate like how inefficient that is, and also consider how long it would have taken him at a normal pace on a straight line. So I'll try to explain that. So riding at 5 miles per hour and traveling 1 mile, well, on a straight line, that would take him 1/5 of an hour. obviously 1 over 5, right? However, we also need to consider how inefficient going in semicircles is. So let's say that the straight line here is x. Well, the circumference of a full circle would be x times pi. But since it's only a semicircle, it's going to be x times pi over 2. And so basically what the question has done is it's saying that instead of traveling x distance, so he's going x times pi over 2 distance instead of going x distance. So that's going to take him pi over 2 as long, basically. So like if x is 1, instead of traveling 1 to get this far, he's traveling pi over 2 to get that far. And so that's going to take him pi halves as log. I think this part might be a little bit confusing. Did everyone understand? Okay, well, so if we multiply these two, we'll get pi over 10. And so that's how long it'll take him to cover 1 mile. Let me try to explain the last part again, because it might have been confusing. So pretty much instead, we're trying to get from this point to this point. Now, normally, he would have just gone in the straight line, which would be x distance, but instead he's biking x times pi over 2 distance. So the time it takes will also be multiplied by pi over 2. And we take our pi over 2, multiply by the normal time, 1/5 of an hour, and we get pi over 10. So we've basically taken the normal time and multiplied by sort of a factor to account for how inefficient these semicircles are. Okay, so those were all the problems for the 2014 AMC 8. If you found this helpful, please consider donating to my GoFundMe, which is to help support hospitals for COVID-19. Thank you.